first step to calculate the DC panel that I need for my new boat is this. Verify where should be located the DC panel and avoid proximity with the AC panel. I have a lot of experience doing wirings like this. I don't like boats where the DC panel and the AC panel use the same compartment and both of them are together. I don't like that because soon or later you can make a mistake and you produce a short. You need to make a list of all the equipments that we are going to connect together on the DC panel. Okay, I am going to install 5 blowers, I am going to install lights, I am going to install all the DC equipments. You need to make a list and in front of the list put the capacity of each equipment in amps per hour. Because according with that information, where is located that information? In the label of the equipment. The label says the voltage and the intensity, the consumption in amps per hour. With that consumption, you select the breaker for that equipment. In this particular case, this panel, the front of this panel is this. With the ammeter, the voltmeter, and the breakers, the individual breakers. In the back, it's exactly like this. This is the positive bus bar, and this is the output of the breakers. This is the voltmeter and ammeter. Voltmeter and ammeter. Right now, I am going to explain the procedure to connect each instrument and the procedure to do the troubleshoot on this panel. The next step is verify how many extra DC sub-panels will be working from the main DC panel. This is a very important information. Some boats, some manufacturers prefer install the main DC panel and that panel should be the manager of the rest of the small DC panel. Let me explain that. Some manufacturers, they have one breaker in the main panel and that breaker says electronics. When you activate that breaker, electronics, you send power to other small sub-panels, like the panel that you have on the screen, for electronics. Radar, GPS, transducer, all of those electronics equipment receive power from this main breaker electronics located in the main panel. This is good in order to take administration from one central point. How many negative bus bars are in a typical boat? A lot. You found it in the console, one negative bus bar. You found it in the kitchen, other one. In the saloon, other one. In the engine room, other one. There are a lot of negative bus bars. You need to verify how many of those negative bus bars I am going to install and verify that all of them should be connected together and connected with the main negative bus bar on the DC on the engine room. The bilge pumps should be powered all the time without any breaker. Why? Because you need that the bilge pumps works all the time. Doesn't matter if you turn off all the switches, you disconnect all the switches, those equipment, the bilge pump, they have power all the time. Those equipments like the bilge pumps should be connected from a constant positive bus bar. A constant positive bus bar like this. This is a constant positive bus bar coming directly from the battery bank. This is a constant positive bus bar. What is the function of this? I am going to connect the bilge pumps. The bilge pumps receive the power directly from this point. The final is using a drawing tool for engineers. Try to make a professional wiring diagram following all the marine safety regulations and rules. This is very important. A professional wiring diagram. You need to give to the manager of the project and to the customer the wiring diagram in order to integrate that wiring diagram into the catalog of the boat. This is very important, and additionally you need to give to them a USB drive or a CD with the wiring diagram, and I recommend that you keep in your files in your office copy of those wiring diagrams. 100% sure in 10 years or 5 years or 20 years, they will call to you asking for that diagram because they need repower the boat, rewire the boat, and they need that information. If you have that information, will be easy for the new contractor rewire the boat. Use a screwdriver in order to lose the terminals and tight the terminals on breakers. Use a screwdriver, hand screwdriver. Never use impact tools like this. If you try to use that one, you damage the head of the screw and you destroy the plastic on the terminal, or you destroyed the breaker, or you destroyed the relay. Never use impact tools. Exactly the same when you try to tight terminals on the relays. Use appropriate tools. Use the properly wrench, the appropriate wrench. Never try to fix those terminals. Never try to fix those terminals with adjustable wrenches. This is not good. You make chores, you damage the head of the bolt, and never try to use pliers like this to fix it because you destroyed the equipment. This is expensive equipment. Never use those tools, are not appropriate. Remember, previously to this video, you calculate how many breakers you need in your boat, the capacity of those individual breakers in amps per hour. In some DC panels, you have a main breaker. In big panels, you have a main breaker and the individual breakers. In this small panel, I only have the separate breakers. I don't have main breaker. All right. The first step is calculate the gauge of the wire coming in with the power from the battery switch selector. If you remember, in the battery switch selector, you have terminal 1, terminal 2, and the common. From the common, in this particular example, you have two cables. One big cable for cranking, and other small cable in order to bring the power from the batteries into the positive bus bar. This small wire was calculated according with the capacity of this panel. This panel is maximum 25 amps. We use that cable, that wire, for 30 amps. And from the common, we have two cables. One small wire for the panel, and this is the wire going out into the panel and entering here into the positive bus bar on the panel. This cable is protected with a fuse. This cable, according with the capacity in amps, is protected with a fuse. And this is the fuse. This is the fuse used to protect the panel. We are going to return into this point. This cable fits the common positive bus bar in one side of the breakers. The other side of the breakers is the output in order to activate equipment. For example, this breaker is for this pump. Yes. Alright, right now I am going to explain the procedure to install the voltmeter and the ammeter. If you remember, in a previous episode, I explained that the voltmeter for a DC panel should be connected. The positive of the voltmeter connected to any part of the positive bus bar, and the negative of the voltmeter connected in any part of any negative bus bar. In this particular case, this negative bus bar, because it's pretty close into the panel. Okay, the negative into the negative bus bar, and the positive here in the positive bus bar. And right now the voltmeter is working. Now, for example, I want to know the breaker number 2 is the breaker for the blower. I want to know what is the consumption of this blower when the blower is running. I am going to use my ammeter. Okay, I am going to put my ammeter here, and in this moment the breaker For the fan is off. The fan is not running. What happened when I close the contact on the breakers? The fan starts. Alright. In this moment, the contacts for that wire, the positive wire of the fans, are open in this point. What happened if I connect my ammeter right now in between this point and this point? Of course, the fan starts and I read how many amps is the consumption. 2.4 amps. Once again. Let me explain how is connected this ammeter. You remember the positive cable to enter in the positive bus bar? That's the positive cable, the positive cable, the positive cable, okay, here. This is the chan. And this is the other end. Enter into the fuse and goes into the switch selector. Okay, this is the power coming from the battery, pass through the fuse, and after the fuse, enter in the chan and continue and goes into the positive bus bar of the panel. On the side of the chan, there are two small connections where I connect both small green cables, and those small green cables enter here into the ammeter, and this is the connection for the ammeter. The voltmeter shows 12 volts, 12 point something. The ammeter, nothing. Let me apply load and you see that the needle goes up. You see that the consumption in amps, DC ammeter, you see 10 amps, that's the consumption of the fuel pump, you remember? And you remember the other one, the blower, the consumption is 1.2, exactly, excuse me, 2.4. 2.4 plus 10, 14, plus the lights, that's the consumption of the panel right now, around 15 amps.